All right, now we have just finished making a load measurement on this sample A, and in addition to looking at the waveform in this portion of the screen, if we click on the graph button, we can actually see the percent modulus change as a function of the coupling pressure, the measurement that we just made. So we'll go back to the waveform, and now we're ready to make an ambient measurement, and we need to reconfigure the sample for the ambient measurement. If you notice on the right portion of the screen, it says load dependent, and we just made that measurement. And if I had set up the B and C sample by clicking this down arrow key here, we could also select a second sample to make the load measurement on. But we're going to go on and now select the ambient measurement. So we click Configure Sample. We go to Run Setup. Since all of our dimensions have already been entered, we don't need to repeat that, and we'll select Ambient Measurement Sequence. And I click that on the left side of the screen. It says that this is going to be the SAE J2725 procedure. The first mode to be measured is going to be the V33. So I will need to swap out my transducers to start with the V33 since I currently have the shear wave sensors in place. To take a look at what the total list of measurements for the J2725, I can click on the Advanced button here, and under Mode Sequence, we see that we're going to be doing 4 V33 measurements, followed by 3 V22, 3 V11, and then we're going to go to the shear measurements and do 3 V32, 3 V31, 3 V21, and then we'll switch the sample out and measure our 45-degree sample, and we will make 4 of those measurements. So I'm going to click on Done. And notice that on the right side of the screen, where it said load dependent before, it now says ambient. I'm going to set my sample back on its card. I'm going to change the transducers because I know the first measurement is going to be a V33. I have the compressional transducers in place. I'm going to put my sample back in, and a V33 measurement, with the compressional waves, the orientation in the plane is not crucial. But again, just for consistency, I'm going to place it as I would for a 3-2 measurement as well. So the sample goes into place. These measurements are typically done at about 700 newtons. For this ETEK, I need to switch back to the longitudinal and go up to 700 newtons. I'm going to click Start Run, and I'm going to adjust my window here so that I will be measuring the first peak on the waveform. And I'm pretty close to, the prompt says apply 694 newtons. And we want to measure the first peak, and then click Accept. And I'm going to repeat this measurement a total of 4 times. All right, I've made 4 V33 measurements. I will raise my sensors and orient the sample so that it is sitting on its side so that the sound wave is going to travel through the two direction. And the prompt says 518 newtons. Again, the friction material is not load dependent in this direction, but for consistency's sake, we will apply the same coupling pressure of 4 megapascals. I needed to reduce my gain. Typically, the in-plane direction, the signal is much higher than in the through the thickness. So I click Accept, and I'm going to do 2 more V22 measurements.
Go.
And now we're going to orient the sample to measure it in the 1-1 direction, so it's going to be sitting with the long dimension. And we're going to apply 544 newtons. And I need to adjust my cursor to measure the peak. Accept, move the sample, and click the accept. Okay. Now that we've completed the longitudinal measurements, I changed my transducers, flipped my toggle switch so that we're going to be measuring with the shear wave transducers, and I will put my sample in. Again, with the shear wave, we need to be conscious of the orientation of the stems. So the 3-2, just as when we made a load measurement, the sound wave goes through the 3 direction and the stems are parallel to the 2. And the prompt says 694 newtons. And I'm going to increase my gain a little bit. And click accept. Now, a lot of times we get asked the question, oh darn, I clicked on accept, but I made a mistake. I clicked too soon. Can I correct this? And the answer is yes. If you take your cursor and go over the corrected transit time and then select the corrected transit time from the screen, you can actually type that value in. And then click on Apply Changes to the Table, and it says these changes will be written to the database after the measurement sequence is complete. So that's how, if you make an error, and I could even go back up to an earlier measurement, as long as this sequence has not been totally completed. Okay, so I'm going to need to make 2 more V33 measurements. I move the sample, click accept, move the sample again, and keep in mind we can rotate the sample 180 or flip it over. But for the next measurement is going to be a V31. I just rotate the sample 90 degrees. So this is a different mode if I just rotate it 90 degrees. Apply 694 newtons, click accept, move the sample, click accept, move the sample, click accept again, and now we're on to the V21 mode. The V21, we want the stems of the transducers parallel to the long axis of the sample, and the sample sitting upright so that the sound wave is going through the medium direction, which is our 2 direction. And we apply 518 newtons of load, and again move our white vertical lines so that our yellow measurement point is at the trough. Click accept. I can again rotate the sample 180, click accept, flip it over, and click accept. And now we're ready for the 4-5 measurement. I remove my rectangular sample and pick up the 45. Now, as you may recall, with my block sample over here, I want to be measuring through this dimension here. So with our cut sample, it's a little bit small, but the side view, so that the stems are going to be parallel, looking at like a parallelogram. And I need to apply a little bit of couplant to this sample. And the prompt says 544 newtons. We've got a nice waveform with 2 troughs, and the measurement point is the second trough. Frequently, because these samples are relatively thin, we go a little bit easy on the load. We don't necessarily apply the full 544 newtons. I'm going to move my cursors to measure this second trough and click accept. I'm going to rotate the sample 180 degrees or flip it over for a total of 4 measurements. Okay, and that completes the ambient sequence.